getting into my groundwater, and the proof is in the pudding. Water doesn't normally do that. Problem is, if you say this wrong, nobody's going to take you seriously. Look, groundwater is really high up. Groundwater is just below the surface. We say groundwater is deep at 100 feet. We say that groundwater is effectively impossible to get at 500 feet. That's up here. Then there's bedrock, then there's more rock, then there's more rock, then there's cap rock, and cap rock is impermeable. Otherwise, your natural gas wouldn't be underneath it. So, groundwater, 7,000 feet, that's where the natural gas is. This does not migrate to groundwater. Fracking itself doesn't put fracking fluid in your groundwater. So what's up with this?
Improper waste disposal.
Yeah, idiots on the surface. I want to be really, really clear about something, because if you go have an argument with somebody who's in the fracking industry, they'll be like, no, there is no evidence that fracking puts fracking fluid into groundwater, and they're right. What there is plenty of evidence of is, idiots can spill stuff on the surface. Like, I can put Tapatio in groundwater. You just wait, because the surface all goes to the ground. So we have gasoline in our groundwater, we have paint, we have pesticides, we have solvents, because idiots on the surface. You may have ruined some groundwater, I probably have. We all ruin groundwater on the surface. So let's be really clear about something. This lady has a reasonable complaint.
Why is she so calm about it?
Because she does this all the time. Somebody just showed up to take the picture. Tonight and tomorrow night, I'll show you a documentary that was on HBO a few years ago about people who can light their tap water on fire. And they go to some poor dude's kitchen, and he's like, y'all ready? You rolling? And he just puts a lighter up there and goes, when he makes this big old flame. And you can see the cameraman kind of jerk the camera, and the interview guy scream, and the dude's like, and he does that all day. It's just a good stunt. There's a lot. It's cheap. It's clean. We have it. Fracking fluid. There's a lot of controversy about this groundwater stuff, and I think we get the argument wrong. You probably already have this in your notes, just to remind you. You don't need word for word. Don't waste your time. The slide's leaving in a second. I would like to give you my 4 complaints about groundwater. Sorry about I'm not good with words. My 4 complaints about fracking. Jose's complaint numero uno. Fracking consumes a tremendous amount of water. In many states, this is the #1 use of fresh water. And by the way, they usually use drinking water.
Why?
Because they need consistent chemistry to work with the fracking fluid. So if you use wastewater and salt water, then the chemicals don't work right. So if you have a recipe that works in Minnesota, I got to take that to Pennsylvania. And so drinking water has a standard. Tremendous water volumes. Number 2, waste disposal. And if you're looking to get rich, this is the boom market. Fracking is honestly not that profitable because anybody can do it these days. But the one constriction in the system is figuring out how to dump all that fracking fluid afterward. If you can figure out how to pump that into the ground where it'll stay put, you can make so much money. Waste disposal is a booming economy getting rid of all this fracking fluid. Number 3, I got a really big problem with surface contamination of groundwater. And that's true of gasoline, and that's true of farms, and that's true of cities. We all pollute groundwater, and we shouldn't, because we should be drinking that. But we gotta be clear, the one fracking impact on groundwater is surface contamination. Like, that's a legally defensible argument, just get it right. Don't say that the fracking itself contaminates, because it doesn't. Different parts of the crust. Finally, argument number 4. I'll tell you that lady's story. She lives in a cancer cluster, a bunch of her neighbors are getting sick, everybody's water is nasty, all up and down her street everybody lights their water on fire. Everybody's like, this all started in March, right? Like, isn't that the month that fracking guys showed up? And fracking guy's like, it's not my fault. And everybody's like, I'm pretty sure it's your fault. And I draw a map around fracking guy. And he's like, and everybody's like, fracking guy, right? And he's like, not me. And this lady goes, look, I've measured hydrocarbons in my water. And fracking guy goes, it sucks. And everybody's like, but the fracking guy, like, he's the source of the hydrocarbons, right? And they go, bro, what's in your fracking fluid? And he goes, top secret. And he doesn't have to tell you. You can't track the fracking fluid traveling in the water, because fracking fluid is secret recipes, because industrial secrecy. Like, you're allowed to, you know, it's like a, what do you call that? Patented technology. I get really pissed when patented technology starts to rub against public health. For me, that's like not.
Is that number 4?
So number 4 is secrecy about fracking fluid. We have a lot of legal battles to find out what's in the fracking fluid. I think that like forcing people to be transparent about fracking fluid would make a lot of sense. Hi. Anybody want to talk more natural gas? 23 and 24 go really fast. Please look up. 23 has a slide that you don't need to copy word for word, but I want you to look at the picture and then look at my hands for just a minute. Please look at the picture first. Because fossil fuels are mixed together, any place that has coal will also have some natural gas mixed. That's just because they're always mixed together. And the technology to get those bubbles out of the coal is super simple. You just force water through the coal. And the water that comes out the other side is fizzy with natural gas. It's really simple. We have a lot of coal, and we have a lot of natural gas, and we know how to get the natural gas out of all that coal. And one last problem, the water that just went through the coal is really, really gross, so we basically don't bother. Because like washing coal gives you dirty ass water, right? So that's what the slide says. It's called coal bed methane. The US has a lot. Because they're mixed together, it's easy to get, and we don't bother. I'll give you 15 seconds. Coal bed methane, US has a lot. Easy to get. And we don't. Because of the slurry. The coal water is nasty.
And can you not use the coal anymore?
I think you can, actually. I don't think it degrades the coal substantially. Coal dries.
Is there a way to clean the nasty coal water?
I think it's just not offset by the like, yes, you could pretty much pull anything off, but the cost of that would be greater than the benefit of selling the natural gas, you know?
But soon it won't, once the,
Yeah, I mean, I understand your point that if natural gas runs out, the price would go up, but probably the energy cost of cleaning the coal will go up, or cleaning the water would go up. Separate from both of those, like coal bed methane is like a old known, like this is not cutting edge in any way. This goes back to like, I don't know, 1930s or something. And it's my understanding that it's another source of methane that we have dismissed. Yeah.
What do you mean by like they mix together? Like,
Yeah. All fossil fuels are mixed deposits. Because like if you're taking a whole like swamp and you're squeezing it under layers of rock, some of that's going to make solids, but a few of those carbon compounds will by statistical probability make fluid, and some of those will make short chains that are gases. So the formation of fossil fuels results in a blend of phases. Because they're not homogeneous. Like, it's like a big pillow sack of Legos. That's not going to make perfect blocks of 4 Legos every time. You're going to get some weird lumps. Then study goal number 24 is another giant source of methane that we really can't use. Chemistry alert. Messed up my water. Alrighty then. Please look up. H1, H2O. Another H2O. Steam. Water. But when these things settle down to make ice, there's like positive charge, negative charge, so they space out funny. So when they go to make ice, the liquid will expand into this shape. Raise your hand if you knew that water expands when it makes ice. Good job, babies. Good job. So here's me trying to figure out how to build. Something's not right here, by the way. I don't know how I got this job. Okay. I lied on my resume. Fine. So there we go. I kind of built some ice. Okay? That's ice. Way over here where other stuff is happening, the decomposition of carbon compounds makes methane, and methane is a really small, tight molecule because carbon bonds are really strong and hydrogen is really light or something. So methane is like really tight. So here's methane. You can always remember that anaerobic decomposition makes methane because you can light your farts. There is air in your stomach, so aerobic decomposition makes burps, and you cannot light your burps. There is no air in your intestines, so decomposition without air makes flammable gases. Should we take a moment for your edification to talk about lighting farts?
Should we test it?
I'm not really available for that. No.
does it like
I could try, but it wouldn't end well. What?
doesn't actually work, does it?
Oh! Totally not. Yeah, don't worry about it. Anybody ready to blow some minds? Am I the only person here who's lit their farts? Kids these days are trash. You are a wasted generation. Quit using my oxygen. Get out of the way. You make traffic. Are you kidding me?
I've seen someone else do it.
Pretty close, I guess.
My sister accidentally let
I have like a PhD in lighting my farts.
What the hell is that?
CEO of lighting these farts.
I'll be quiet.
Like,
Sadie, stop. That's bullying.
You have a lighter here if you want to stop.
I know. I remembered. I'm tempted, but YouTube. Okay.
You've already put enough on it.
The memorable. Yeah, I know. I'm already dude. Please don't fire me. The memorable thing that I want you always to hold on to. I don't really care if you light your farts or not, but I do want you to remember that farts are actually flammable. That's real. Because anaerobic decomposition, there's no oxygen. So instead of making carbon with oxygens, you make carbon with something else like hydrogens. And that's methane, natural gas, is flammable. Nice one. So, what would happen, please look up, if we have things decomposing anaerobically at the same time as you're making ice? It gets stuck in there. And I'd like you to put something in your notes. This is not a bond. It's a hydrate. It's not a bond. Which means it's something stuck in water. That's a physical thing. Look at me. That's not bonded. Can you all see that the methane is moving? It's not bonded. This is not a chemical bond. The ice is still ice. When the ice melts, it's still water. This is just trapped. It's in little chemical jail. It's not an air bubble, because it's like at the compound level, it's smaller than an air bubble. So like anaerobic decomposition where ice is forming will make ice that has methane in it. That's called methane hydrate. Please look up. It's the coolest thing in the world. Snowballs that catch on fire. Snowballs that catch on fire.
What?
Yeah!
Yeah! So you can see the compound in the upper left-hand corner. You can see the compound. Methane is just this little molecule that's small. So when the ice is spacing out those water molecules, it just like, boop, just has another thing in it. Yeah,
Theoretically, if I wanted to make flaming snowballs,
it is doable.
how?
I don't know, but at UCS Brodog they can teach you because I've seen it with my own two eyeballs.
Awesome.
There was this one lab where I would go get my liquid nitrogen because I had to cut the heads off guppies and then freeze the heads and then put them in a bead blender to get the DNA out.
Oh my god. Awesome.
That's science.
So many good things.
No, we would sedate them first, so they just went to sleep and then we cut their heads off. And then...
That's so sad.
Yes. Okay.
It is totally. Protein smoothie.
Don't say that.
Don't listen to these.
And one day I was walking through the halls to go get my liquid nitrogen, and I see my homie, and I'm like, "What's up, homie?" And he's like, "Hey, look, we just did the coolest thing. You're gonna love this." And I'm like, "Okay." And he like opened up a little like fancy cold case thing, and he took out this like little styrofoam box, and inside the little styrofoam box was like this snowball. And he's like, and I was like, and then he like talked to his homie, and he's like, "All right, you ready?" And I'm like, "Jose, you want to stand back a little bit?" And I was like, "What?" And then like it immediately caught on fire. And what's crazy is the heat makes the water melt so that more methane is released so that it melts faster. So the flame starts to get bigger and bigger as the thing starts to pour water out. So your hands are freezing because you're just pouring ice water over your hands.
Will it burn
And
you?
meanwhile, your head is getting hot, like, oh god, like it gets really hot.
Will it burn you?
I guess, like, if you were over it.
No, but like if it's in your hand, will it burn your hand?
No, because, like, the last of the gas will be released while you still have a coating of water. So you just get colder and colder and colder until your hands are just wet.
Cool. Good to know.
Yeah. And as far as anybody can tell, like my daughter, it's indistinguishable from regular snow.
Yeah, she's
Yeah, look at how stoked she is. She was such a cute kid. Now she's almost your age. Ugh. Ugh.
We're turning that on YouTube.
I wouldn't waste the methane hydrate on my daughter, obviously. That's just regular snow. There's two types of methane hydrate, the bottom of the ocean and permafrost, because there's two places where you get freezing conditions plus decomposition. They're called oceanic or Arctic deposits. Oceanic or Arctic. Oceanic or Arctic deposits. The planet has a bazillion of these. And again, like the coal bed methane, there's no viable way to do this because nobody wants to put a power plant at the bottom of the ocean or the Arctic. And yeah, you could go dig up huge snowballs, but it's kind of tough to transport ice because it melts. And then trying to keep it cold isn't worth the energy benefits.
What is this stuck on?
Your IQ? Like this. Heyo.
It's the bottom, not the top.
Sure. Children, this is another place where we have a ton of methane that we just can't feasibly get. So methane hydrate is not important as an energy source. It is important. Can anybody imagine the problem if I told you that methane is a greenhouse gas?
It's just letting itself into the environment uncontrolled and
Because the Earth is warming up and the ice melts and then it goes into the atmosphere.
And then what?
Greenhouse gas.
And then what?
It
And
gets
then we all
water,
die.
and then it melts more, and then it gets water, and then it melts more, and then it gets water.
It just
Did y'all hear what she said?
Interesting reaction.
He's really excited about our doom.
Excuse me, this is called a positive feedback loop, and methane hydrate is the scariest one in climate models. Methane hydrate is the primary runaway chain. It's the biggest snowball effect.
I get it.
It's the largest positive feedback in the Earth's climate. Let me try to say that again. It's the largest positive feedback in the Earth's climate, meaning that once you get it going, it gives you the most continued going. There's probably 6 degrees of global warming in methane hydrate. Tremendous amounts. It's way hotter than CO2. 10 times hotter than CO2. And there's a lot of methane that's just waiting for the warmth to go out and make more warmth to make more go out to make more warmth. First?
What if it's not really feasible to get it? Why does it say recovered? Why are the yellow ones?
Those are places where they've like sampled it and found it, I believe.
And the
I
other
don't-
ones, they just think it's there.
Yeah, it's like, hey, we got it, but that doesn't mean it's like a usable like energy product there. Yeah.
So, even though it's not like feasible to be used as an energy source, is there some sort of like way to prevent the melting, or at least catch it while it's melting in the cycle?
I think if you light it on fire, you cut 90% of the heat gain. Because if you light it on fire, it becomes CO2, which is less hot.
So we should light the Arctic on fire.
Yeah.
Cool.
Yeah, it should be a big old fire, yeah.
Which would just end up melting all the ice anyway.
Heyo. Or we could just kick back on the fossil fuels, but nah. Okay, that was exciting. Now, number 25, I think, is one of those study goals that I'd like to imprint on you for the rest of your life, because in your adulthood, I want you to remember this. This is me, like, changing my society by becoming a high school teacher. P.S. It's helpful on the AP test. So, how many of you wrote down 8 things for number 25? Check your homework. You're supposed to have 8 things for number 25. The other 28 of you, what the hell did we stand? On number 25, you're supposed to have a list of 8 things.
It doesn't say 8.
There are 8 bullet points.
You just write down like the small story.
I hope I have your attention. Your failure is not noted now, but it's predicted later. Watch. Number 25 says, outline the environmental effect of oil and natural gas extraction and usage, parentheses, it's a big list. Maybe you just did bullets, but there are 8 things in your book. You won't be able to copy them off me right now. They're the habitat loss from construction, the pollution of surface and groundwater, the accidental release of air pollutants, the land subsidence from withdrawal sites, the disruption of fragile ecosystems, oil seepage in the sea, release of drilling mud, and aesthetic degradation. How many of you had that? 4 of you, great job. 5 of you, 6. Now, I have 9, 10, 11, and 12 for that list. So there's a lot of problems with the petroleum and natural gas industry that we don't talk about. Like those 8, plus the 9th one on your list. Tanker ships are really dirty. Everybody claims to love the ocean, but tanker ships produce more ocean oil pollution than all other sources combined. More oil gets into the ocean from tanker ships than all the runoff from land, plus all the oil well accidents, plus all the oil that comes out of the atmosphere because little particulates are left in the air. If you add together all other sources, tanker ships still account for more oil in the ocean.
Do you know, like, roughly how much?
Well, I know that it's 50% of the ocean's oil. The number I don't know, but you can Google that. Can I have your plastic cup? In case you didn't know this, oil tanker ships are really, really big. So when they're bobbing around empty, they're wobbly and unstable like this. And if you see a big storm coming and you're surrounded by salt water and your floaty cup is empty, what can you do to make your boat more stable?
You put the water in the tank.
That's right, that's called ballast.
Yeah, but the oil was there, so you like pollute the water, and then you didn't know where to put it, so you just put it back to the ocean.
What he said. So you can stabilize an empty tanker ship by filling it with petroleum, but when you get back to Dubai or whatever, you got to dump out that salt water. That's illegal, but extremely common. People's lives depend on it, so it's kind of tough to enforce that law in the open ocean. Tanker ships are really dirty. Number 10 on your list of 12 problems with the petroleum industry. Number 10, oil refineries are also really dirty. This is probably the dirtiest land use. Of all the things that we do on land, this is the most polluting human activity. Oil refineries are really dirty because we have a lot of petroleum. Vocab term for you, this is how we refine petroleum. That says fractional distillation. And again, if you don't know how to light your farts, do you know how to make moonshine? See, kids these days.
Probably figure it out.
Yeah, for real.
Like, how many of you can fit all your arrests on one hand?
Oh my what?
See?
Can you?
Just barely. So the way that you make moonshine is you take any sugar water and you let it ferment into any alcohol. And it's going to taste gross, but there's alcohol in it. You fill a whole bathtub with that. Then you put your bathtub up on cinder blocks and you make a fire underneath the bathtub. And alcohol has a low boiling point, so all the alcohol will evaporate first, and you capture all that steam with like an old blue tarp or whatever. And once you captured all that alcohol steam, you let that all condense back down, and you get a little concentrated alcohol bottle called moonshine.
Yeah, it's so good, bro.
Yeah.
Moonshiners.
Yeah.
Yeah.
Back to me. Back to me. Back to me. The only thing that could go wrong is A, it's explosive, B, it's deadly, C, at the very least, if some of that ethanol gas escapes, you can have heart attacks and blindness and paralysis, so what could go wrong?
180 proof.
Yeah, but it's really strong.
180.
What about the heart attacks?
Oh yeah, that. Please look up that principle about how at a specific temperature the water will not evaporate but the alcohol will, is because alcohol has a lower boiling point. Raise your hand if that makes sense to you. Lower boiling point evaporates at a lower temperature? Okay, good. Now please look up. These evaporate at room temperature. This one evaporates a little bit higher, right? As the molecules get bigger, it's harder and harder to gas them, right? Yeah? So that's fractional distillation. You take all of your mixed petroleum and you let the gas leave. Then you heat it up a little bit, and the stuff that's barely heated will turn to gas. We use that for plastics, pharmaceuticals, pesticides, paint and pigments. Those are all P words. Then we add a little bit more heat, and like the C10-ish chains will evaporate. That makes gasoline. So you take all that steam, you condense it back down, and that's how we make gasoline. You heat up petroleum just a little bit so that the gasoline evaporates out of the mix. Right? Like moonshine, alcohol from water, different boiling point. As you raise the temperature, you get a different product every time. So at 200 degrees, you get 200 degrees, you get diesel out.
Is that why it's more expensive? Because you have to use more heat to produce it?
Yeah. But it's probably some other market forces that are at play here too. At some point you have to dispose of this, so tar's really cheap, but you gotta get rid of it.
Yeah.
So it's gotta be supply and demand, not just energy cost.
It is, because like in Australia, diesel's cheaper. Because it has a market for it.
Oh, don't know. There's too many variables in that pricing. But I can tell you that this is called petroleum refining or fractional distillation. And I can also tell you that's really dirty. Just like moonshining is pretty sketchy, that's pretty sketchy. Except we do that for every drop of petroleum on Earth. In the United States, we do more than half in a single city. In good old Austin, Texas. Maybe it's Houston. Anybody want to correct me on that? Which of those? It's one of those two. Coastal Tejas. Anybody want to tell me what the refineries are? I thought it was Austin, but I'm willing to be wrong.
Oh, you're.
Are you from Texas?
Yeah.
You don't know?
I was there when I was like 7, so.
Not good enough. Okay. Let me down again, Chloe. Okay. Petroleum refineries, wherever they are in Texas, is an extremely dirty job. Making all these things. Think about all the volume that we make in the United States every day. That's an extremely dirty job. Then, number 11 on your list. Each of these petroleum products has to be moved around the country. All of the ingredients for chemistry go to New Jersey. All of the tanker fuel goes to the coastlines on ships. All of the jet fuel is delivered by trains to airports. All of the gasoline is delivered by trucks to every city in America. Think about all of our transportation infrastructure carrying explosive, flammable nastiness.
So it's dangerous.
Right, number 11 is the danger of transporting this around the United States. Like, if you pay attention, there's like some big train accident or some big freeway accident like every couple of hours in the United States. These are like really bad habits that we just don't see because they get lost in the noise. It's not really news if it already happened yesterday. Yeah?
Why do all chemicals go to New Jersey?
Because of the 8 Mile. Yes. Eminem. Raise your hand if you know a skinny white guy, Eminem rapper guy. Grew up in a little part of New Jersey called the 8 Mile. That's like the industrial chemistry capital of North America, and like that's where they make all the pharmaceuticals.
Detroit.
He's from Detroit.
Crap. So maybe it's in Detroit, not New Jersey.
Maybe watch the movie.
But I really thought it was New Jersey, but you're right, it's Detroit.
Yeah, join our Eminem fan club.
Maybe there's 2 8 Miles, so it's not
Dude,
Eminem.
they all missed a club.
Oh, my story sucks. I thought that these were the same thing, and now I question everything.
You should get an after school movie.
Somebody want to Google this? The industrial chemistry 8 Mile. I think that is New Jersey. So what's the 8 Mile reference in Detroit?
It's like how long it is, like the neighborhood or something.
You want to Google that? What's the 8 miles in Detroit?
8 Mile, really.
All right. In the meantime, since I've lost my credibility with this Eminem reference, I just want to remind you that number 11, moving this stuff around the country, is really nasty. And finally, we get to number 12. The only thing we ever talk about is number 12, how nasty it is when we light those petroleum and gas products on fire. Number 12 is the air pollution of lighting things on fire, the climate change, the smog, the acid rain. Air pollution from burning fossil fuels. There's just one thing that frustrates me. Just one thing. Our entire social conversation.
It says 3 over 8 miles.
Great.
So it's 3/8 of a mile.
I mean, it
That's
says
the ball.
it's just a bunch of fractions.
I think you look at the wrong thing.
No, because it's under the Journal of Industrial.
Okay, back to me. Maybe it's a 3/8 strip. I don't know. Okay, back to me. Our entire social dialogue about fossil fuels and their impact on society is on number 12. All we ever talk about is number 12. If you and your mom are having a debate about the fuel economy of her new car, it's going to be about number 12. And when you go take a physics class and they tell you that there's air pollution from fossil fuels, it'll be number 12. And we never talk about the habitat loss for building infrastructure for fossil fuels. We never talk about the subsidence from extraction. We never talk about drilling muds. We never talk about tanker ships. We never talk about transportation. We never talk about the coastline of Texas. Here's my problem. Fossil fuels are an inherently dirty thing that's dirty at every step. The College Board often asks you, name one problem other than the CO2. Or other than the obvious one. They'd say, name one problem with fracking other than groundwater pollution, for example. So I always want to give you bigger picture, more problems. You know, like imagine if we had a debate about heroin use in America and all we talked about was like it makes your teeth brown. Like that's not wrong, but we're missing the bigger picture, which is there's a lot of other problems too. So it's true that petroleum and natural gas cause air pollution and climate change and smog and stuff, but there's a lot of other problems too. That's an important study goal that you just skipped in your homework number 25.
So it's just that it's dirty all the time?
That it's dirty all over the place. Like if somebody said you can burn gasoline without air pollution, I still wouldn't want it. You know what I'm saying? Like there's a lot of other ways that gasoline is dirty. It's not just the air pollution when you burn it in your car. Like yeah, if you fix the air pollution in cars, that's nice. But gasoline is still horrific by the time it reaches your car. It's already done those 11 other things before it gets to be an air pollution problem when you burn it. Like heroin without cavities would still be pretty bad. Can we do study goal number 26 so that we're done with cold, please? How many minutes do I have?
2.
A minute. 30 seconds. No minutes. It's over.
You're all the worst humans. Does anybody want to do the
It's
extra?
2
I
minutes.
thought it's 59.
Class ends at 10:01.
10:01?
Yeah.
Wow.
You're such a miserable liar. God, it is 10:01. Okay.
Thanks a lot.
Look. How many of you know that plants have a lot of little tubes that move water around?
Roots.
Those little tubes, they're teeny little straws. The structure of those little tubes is made of a chemical bond called lignin. And when you grind up a plant, you just get pieces of those tubes called peat. Please look up. I need you to add these words over here. Peat is little ground up pieces of plant. Lignin is the chemical compound that makes those tubes. Wherever you made that little drawing, peat is little ground up pieces of plant tube. Little ground up pieces of plant tubes. And lignin is the chemical compound that builds that structure. So please look up. These are a bazillion little pieces of plant tubes. And we're going to have to come back to discuss lignin on Thursday. And we're officially about 10 minutes behind the other periods, but we kind of caught up a little bit. Don't forget your energy use inventory.
I have a question about that.
Oh, what?
The energy use inventory,
You get the
you need to measure, do they always have to be plugged in, or like, can it be your phone, chargers?
I don't know that you'll get it from a phone, but it can be stuff that's only on a few hours a day.
Yeah, like if
Can you
like
turn that off for me?
charge your computer with like a 45 watt thing.
It would just be however